So, hello everyone. My name is Carl Leonard, and I'm going to discuss today the General Motor program about inefficient running patterns and efficient running patterns, and talk about the differences between the two. I'm going to demonstrate a little bit about the wrong way to run, and I'm also going to try and demonstrate the right way to run. So basically, the muscles that are being used during an inefficient running pattern are basically all of the muscles that are considered stabilizer muscles of the body. The lower extremity muscles that I'm talking about that are being used inappropriately during inefficient movement patterns are basically the anterior tibialis, the rectus femoris, and the iliotibial band. These three muscle groups primarily will become injured when they are used incorrectly. Primarily, they are used during the heel strike, overstride heel strike running pattern. So this is what it kind of looks like. I'm also going to attach a video that a friend of mine put together several years ago, about in 2012, when we started this whole efficient running program. His name is Dr. Mark Cucuzella, a good friend of mine, and we kind of use I use his information, and I let the airmen and PTLs in the Air Force basically use the video and learn from it. But an inefficient movement pattern typically use the wrong muscle groups, which are considered stabilizers. So I'm going to try and show you an overstride heel strike pattern. Hope y'all can see this. So notice that when I was running, I was hoping you could see that the stride is elongated, where my heels and my feet are landing in front of my center of gravity. This causes certain muscles that are not required to take on certain amounts of load to work hard. Again, it's the anterior tibialis, the quadriceps, or the rectus femoris. Basically all the muscles of the front of the leg are being worked, and the hip stabilizers as well. Let me demonstrate it one more time to see if you guys can see it. So when an individual lands with their feet out in front of the body, basically that's considered dysfunctional loading. And dysfunctional loading will bring me to my force of muscle contraction here in just a minute. So when we properly land, okay, the muscles that are being used are typically the muscles that propel us forward. Those muscles are typically the glutes, hamstrings, and the gastroc and the soleus. Basically all of the muscles behind us. All right, we're talking about the glute maximus, glute minimus, and the glute medius, hamstrings, gastroc, and the soleus. Okay, those are the muscles that propel us forward, and I can demonstrate that. Kind of quick, because typically the cadence of running should be 180 beats per minute. That allows us to use the proper muscle groups and forces us to land underneath our center of gravity, using the ball of our feet, okay, using the glutes to propel us forward, all right, and the calves are used as a spring gives you kind of a springy sensation when you use the proper muscle groups. So the order of activation of the muscles, basically this is kind of what I just said. Start off with proprioception or ground feel, starting from the bottom of our feet and work our way up forward, and also the ground feel of the proprioception causes the core to engage as well. When we have an inefficient running pattern, the order of activation is kind of, it starts from the bottom, but as it's working its way up, it's utilizing the improper muscle groups or the stabilizers. So the force of contraction, basically the force of contraction should be minimal. All right, when you run correctly and you run with 180 beats per minute, basically your stride or your cadence is quicker. And when your cadence is quicker, your feet move quicker on the surface, which doesn't allow the muscles to stay contracted a long time. Okay, so our typical running cadence is 180 beats per minute. It kind of sounds like this. Okay, this is called a metronome. And this metronome is right now set at 180 beats per minute. So this is kind of what it looks like to run in proper cadence. Basically starting at standstill, you start the metronome. It's kind of what it looks like. So all you're doing now is just basically leaning forward. You can do it slow. And eventually you can pick up the pace. But staying at 180 beats per minute is going to allow us to correct any deficiencies that we have. This is what I use with a lot of the airmen and soldiers and all the civilians that come and see me when they want to learn how to improve their form or improve their performance. The duration of the muscle contraction should be minimal. Okay, obviously the force of the contraction when we sprint is going to be a lot more. All right, but we're not talking about sprinting, we're talking about efficient running. Efficient running, when properly conducted, your chances of injury are very, very minimal. The amount of force that you're using is low. Okay, and you're going to become a whole lot more aerobically efficient as well, but that's a whole nother topic. Okay, so real quick, muscles used during efficient running patterns are the glutes, the hamstrings, calves, soleus and the calves and the gastroc. All right, the order of activation starts from the bottom, and basically, we're talking about proprioception or ground feel. Once those muscles, once the feeling is felt down the bottom, it's going to immediately contract muscles from the bottom and work our way up. Okay, which also includes the core, which is the pillar of the body. All right. The force of muscle contraction, basically, it should be minimal. All right, we're not talking about, and any inefficient running pattern utilizes pretty much the same muscle groups, but it's forcing the muscles of the front of the body to work super hard, and we don't want that. We want the muscles in the back of the body to work for us, to propel us forward. Okay, we don't want to decelerate, we want to accelerate, and deceleration basically happens when your heel hits the ground first, and then everything else follows. All right? The duration of the muscle contraction should be very quick. Maybe I didn't mention this, but during the duration of the muscle contraction for a heel strike, the muscle contraction lasts a lot longer, and that's where the injuries come from. The tendinitis, all right, usually occurs when we have people landing and dysfunctional loading out in front of the center of gravity and then applying 3 times your body weight, okay, for a much longer time period than landing on the ball of our feet with a slight forward lean. It's going to contract pretty quickly because the cadence is quick. All right? Thank you.